The next thing we're going to be able to do today is figure out how to graph log functions based on the domain, the range, finding coordinates, locating asymptotes. All of those things are going to help us to graph a log function. So we're going to start today by looking at this first function, the log base 3 of x. Now, the first thing that I'd want to do is to be able to find the powers of this base. So if I look at the base of 3, the first couple of powers that we can do, if I look at this, I could say powers of 3 are 1, 3, and 9. Now you may be asking, how is 1 a power of 3? Well, 1 is the 0 power of 3. 3 is the first power of 3, and 9 is the second power of 3. So if I look at this, this is 3 to the 0, 3 to the first, and 3 to the second. Now, why do we care about those values? Well, the reason why we care is when I come over here and try to figure out some coordinates of x and y, I want to use those exponents or use those powers of 3 to help me get the exponents of 0, 1, and 2 as my outputs for y. So the inputs I'm going to use are the 1, the 3, and the 9, because those are my powers of 3. And if I evaluate these logarithms, this is going to be the log with a base 3 of 1. And if we think about how we evaluate logarithms, we ask ourselves, 3 raised to what power is 1? Well, that power is 0. The second one here was the log base 3 of 3. And if I ask myself 3 raised to what power equals 3, well, that power is 1. And finally here, the log base 3 of 9. We ask ourselves 3 raised to what power is equal to 9? Well, that is going to end up being 2. So using these coordinates of 1, 0, 3, 1, and 9, 2, I can come over here and graph those coordinates on my axis. So to the right 1 and up 0, to the right 3 and up 1, I can put a point, and to the right 9 and up 2, I can put a third point. But then the question is, how do I connect these up? Because looking at this right side is growing something like that. But then this left side, what's going to happen is it's going to drop down next to our vertical asymptote. Now, how do I know the vertical asymptote is at 0? If I come back over here and look at the inside of my function, just that x value. If I want to figure out how to find the vertical asymptote for this, I'm going to set that inside piece equal to 0. So that x equals 0. And since there's nothing to move off away from x, we know our vertical asymptote is equal to 0. So I can just draw that in as our vertical boundary here. And that would be a graph of the log base 3 of x. Now, not all these functions are going to have vertical asymptotes at 0. So we want to be able to know how to graph when something's been shifted off of that 0 point. The next function we want to be able to graph is this one here, y equals -2 times the log base 2 of x minus 3. Now, there's two things that we can do to start out with. We can either look for powers of the base, or we can look for the vertical asymptote. Personally, I like to look for the vertical asymptote first, especially on cases like this where it has been shifted off of the x equals 0 line. And the reason I know it's been shifted, if I look at the inside piece here, this x minus 3, that tells me I have a horizontal shift off of x equals 0. So in this case, to find this vertical asymptote, I want to set that x minus 3 equal to 0 to solve for where that's been shifted. So if I solve that, I end up getting x equals 3 for my vertical asymptote. So the very first thing I want to be able to do on my graph, I'm going to come over to the right side here and graph this, is put in that x equals 3 asymptote so I know where my boundary is. So I'm going to put that vertical asymptote in and know that I'm always going to be on the right side of that asymptote with this graph because I have a positive x in my equation. So the second thing I want to do is come back over here and look for powers of the base. So in this case, we're going to look for powers of 2, because 2 is the base of the logarithm. Now, powers of 2 in this case, if I do 2 to the 0, that's going to end up giving me a 1. 2 to the first would be a 2, and 2 to the second would be 4. But because of that horizontal shift, everything is being shifted to the right 3. So I'm going to want to take these and shift them to the right 3 to make sure that I end up getting some nice outputs. So values to the right 3 are going to end up being a 4, a 5, and a 7. So now when I look at these, those are the values that I'm going to want to put into my table to figure out some coordinates. So if I do some x's and y's, I'm going to want to use the 4, the 5, and the 7 instead of using the 1, 4, and 2. And the reason I want to do that, if I plugged in a 1 into that logarithm, 1 minus 3 ends up giving me a negative 2, and there's no way I can take a base of 2, raise it to an exponent, and equal a negative 2. Logarithms, we need to be able to stay on the right side of the asymptote, and the asymptote in this case is a 3. Anything on that left side is going to make an undefined value, so I can't evaluate those logs. And so when I look at this one, I want to be able to evaluate it with the 4. So I'm going to take this negative 2, multiply it by the log base 2 of the 4 minus 3. Now there's two ways that I can do that. I can either type this into the calculator using the change of base, that division of logs like we've talked about, or I can evaluate this using the properties of logs. So looking at this, I can see that this piece here inside is going to be equal to 1. So then the log base 2 of 1, I'm looking for what exponent of 2 equals 1. Well, that's 0. So this whole piece with the log is going to equal 0. I end up getting negative 2 times 0, which ends up giving me a 0. So my y value here is 0. For the second one, if I bring this down here for a little bit more room, I've got negative 2 times the log base 2 of 5 minus 3. Well, 5 minus 3 I know is 2, so the inside of this is 2. The log base 2 of 2 is looking for what power of 2 equals 2. Well, that's 1. So this log is going to end up being negative 2 times 1, which is negative 2. And then this final one, if I plug in the 7, I'm going to come down to the very bottom. I've got a negative 2 times the log base 2 of 7 minus 3. And if I evaluate that log, the inside of this is going to equal 4. The log base 2 of 4 is 2, so if I evaluate that, I end up getting negative 2 times 2, which gives me a negative 4 for the output. So we have 3 different coordinates here. We had plug in a 4, get a 0, plugged in a 5, got a negative 2, plugged in a 7, got a negative 4. I'm now going to plot these onto my graph. So to the right 4 and 0 is going to put me right on the axis. To the right 5 and down 2, I can go about right there. And to the right 7 and down 4, it's going to put me about right there. So then connecting up those coordinates on the right side here, I can connect through those and come down to the right. On the left side, I'm going to approach that vertical asymptote and look something like that. So when we just have a log with a base of 2 or a base of 3 and then an x on the inside, there's no horizontal shift. I can just plug in those powers out of the base. In this case, I had a base of 2, but everything got shifted to the right 3, which is why we end up plugging in the 4, 5, and 7 instead of the original powers of 2, which were 1, 2, and 4. But either way, we can still find that graph by plotting a few of those coordinates, finding the vertical asymptote, and then as a result, we get the graph that we see on the right side here.